Sadhana, can you hear me, Sadhana, clearly? Now, please keep your video on. Can you see the screen? Can you see the board, please? Let's just check that we generally do, whether you are able to see the audio video check. AV check. Since this is being your first day of the class, fine. Yesterday's video already I think I have shared with your mom. You might have seen them. What did you understand from that? Nothing pretty much. About trigonometry. Very good. What did you learn about trigonometry? Why should we convert? Yes, for the better. Handling the numbers better. It's convenient for us to handle the numbers comparatively handling the angles. Fair enough. So I might have sounded more like a math teacher rather than a physics teacher, because in your 10th grade, up to your 10th grade schooling, you might have seen the physics teachers not talking about all these things. They would be just talking only about the speed, velocity, and electric current and the related stuff. And here the situation is something totally different, because the mathematical demand on you children is relatively high now. Okay, that's why we have to first learn the mathematical tricks and techniques, so that when it comes to the numerical problem solving, especially, that is the place where most of the children they struggle. In my experience, what I have observed is children mostly they struggle when it comes to numerical problems, and every new problem solving involves solving a numerical involves 3 stages. Okay, what are those 3 stages? Stage 1, you have to read and understand the question first, comprehending the question. It may sound very simple, but this is the most difficult task. Number two is choosing the appropriate equation for that given problem. I have to select the correct equation. That is the second case. And the third is our numerical ability, our ability to take the root. For example, okay, so if you are familiar with all these concepts, I can clean this. Today it is 29. So here we go. Suppose if I write a number root over 16, what's the value? Very easy. So you may give me a number. This is going to be or minus, right? That we can get. Suppose if I give you a number root over 18, what will you do? Do it. Three root 2. Okay. So your friend has given an answer 3 into root 2. So it is 3 into root 2. Let's think what else can be done. 3 into root 2. We have adopted that answer. Same answer. Same answer. Suppose if I get any number like this, I have an approximation trick and technique how to solve this. Suppose if it is a bigger number, How would you do that? And it's a very easily handleable number. What I would do if I were in your place, I would split this number into two parts. This goes this way: root over x plus y. Root over x plus y. I will convert this given number, which is the closest perfect root to this number, 16. So I may write this as root over 16 plus 2. Root over 16 plus 2. Got it? So here it could be plus or minus 1. Suppose if I get 24, then 25 minus 1 can be taken. Got it? So I have a formula for this. X plus or minus y is equal to root over x plus or minus y divided by 2 times of root over x. This is a formula. It's a shortcut formula. So if you try that, you get, watch this. What do we get here? Root over 16 should be plus or minus? Plus. Plus, come on, 2 over 2 times root over 16. I can cross these two. Root over 16 is what, sir? 4. Yeah. So let me write it here. 4 plus 1 over 4 is equal to 4.2. If you try to calculate the answer, you said 3 times of root 2 be the answer, approximately. Got it? Somewhere around 4 to 5% of error for a greater numbers. For this number, it would be more accurate. So this system will definitely work. So like this, you need to have numeric ability. This is what we generally call numerous. The way you, whether you can calculate it properly, or if any number is given to you, are you capable of seeing the breakdown of numbers? Are you able to do the breaking of numbers? So this is very important. So you have to develop the skills to see a number this way. Got it? Got it? Instead of just going with the long division method and the bifurcation method, name it any method. Those are time consuming. And if you just closely observe, you take NEET or JEE, what are they exactly aiming at? What are they exactly aiming at? What is the catch point about NEET and JEE? I'm a JEE trainer. I train students taking up the JEE mains and advanced. Fine. One thing very critical about the JEE and mains, sorry, JEE and NEET, what do they target? What these exams targeted? Exactly. They target our time. You take a JEE question paper and give it to any normal student and give them 2 to 3 days. They will definitely solve those questions and bring back if they are given enough time. But the real challenge is to solve the problems within the stipulated time. So you take NEET exam. In NEET examination, you have 180 questions. 45 questions from physics, 45 from biology, 45 from botany, and 45 from zoology. Altogether, it is 180 questions. How long? 3 hours. That is 180 minutes. So roughly one question is equal to 1 minute. So you are supposed to solve a problem within a minute. So within that 60 seconds, what are the processes that you are expected to do? You have to read the question and actually understand what that author means. The questioner, he wants something and you are supposed to understand his intention. If you miss out a small word, a small point in that, then you will misunderstand the problem. Instead of solving for X, you will be solving it for Y. Got it? That is the second problem. Got it? So first, you have to read and comprehend the problem. Then you have to pull out the right equation. Number 3, you have to substitute it at the right place. And number 4, what are you supposed to do? What are you expected to do? do the correct calculation. If you are going to miss anywhere here, it is not going to work on your. Got it? Got it? So if you want all the wins to be in your direction, so definitely we want you children to focus on these steps. So everything has to be done in 60 seconds. And also then finally you have to recheck your answer and finally shade it. So you have these many responsibilities. Fine. அப்போ உங்களுக்கு அங்கே என்ன இருக்காது, உட்காந்து யோசிச்சு இது கரெக்டா அது கரெக்டான்ற யோசிக்கிறதுக்கே நேரம் இருக்காது. You have to go on a fight mode. You have to go keep kicking. Got it? அது overnightல வராது. You have to practice. As soon as you see a content, immediately your eyes should catch. This is the primary point. This is the secondary point. This is the hidden information. Kind of your eyes should catch that. If you do superficial reading, your eyes may not be in a position to catch. Got it? That is why training is very, very important. So let's proceed further. Rohit, if you want, just you can note this down. X plus or minus y. This is a small trick that we use to find out the value of non-perfect root. But okay, so if any root value, if it is a perfect root, you know how to take it. You can easily find. Suppose if a number is a non-perfect root, okay, so you can split this number into the nearby perfect root value plus or minus some number. For example, if it is going to be root over 24, I can just divide this into what, sir? 25 minus 4 minus 25 minus 1. So this resembles what, sir? X plus or minus y root. In our case, it is x, this is y. So in between, what do I have? Negative. Any number you can, even the decimal you can. Got it? This not necessary. Not necessary. You can take any number. You have to split the given number into such a way that one number is a perfect root, other number is the nearby number. The reminder. Got it? So if you just use this formula, you will get, according to this equation, what is it? Root over x minus y over 2 times of root over x again. This is equal to, in our case, what is root over x? Root over 25 minus 1 over 2 times of root over 25, which is equal to, come on, 5 minus 1 over 10, which is equal to 4.9. Got it? So the root over 24 is approximately equal to 4.9. Later you can round it off to some number, and that depends on the significant figures that your question demands. If you are aware of what is significant figure, have they started teaching all these in your school? No. Are you aware of significant figures? No. Fine. You are aware of that? So I'll teach them little later. Okay. So now let's see something very, very interesting mathematical tool. That's what we are going to take today. Today we are going to talk about something called calculus. What is it, sir? Calculus. Calculus is a wonderful mathematical tool. Is there anyone who knows anything about the calculus? Here, you can just share your idea if you know anything. Yes. Area of a slope. One minute. Please hold on. Hold your gun, buddy. Fine. Area of a slope. Okay, good. My God, this fellow, right, overloaded with a lot of information. So let's stop here. Fine, good. I'm very happy. I'm very happy. This fellow is like an LMG is roaring with all the information. Kind of. Anyway, so let's see, sir, something very interesting about this calculus. This calculus, I will tell a story to you. Fine, listen to my story. Let's imagine your best friend. Okay, came to your mind? Good. Your best friend is coming to your home. Fine, and he or she doesn't know the way. Fine. And Googling is out of option. Fine, sir. So what do? Your friend is calling. I have arrived. How to come? I have come to the bus stop. How to come from here? What you would be doing? Naturally, guiding your friend. நேரா வந்தியா, அங்கே ஒரு ஐசிசி ஏடிஎம் இருக்கா, அங்கேருந்து ரைட் எடு, 3rd ஸ்ட்ரீட்டுக்கு வா, அங்கே ஒரு பிள்ளையார் கோயில் இருக்கா, அங்கேருந்து லெஃப்ட் வா. You know about your friend, that Tarkuri friend. Fine. You give all the directions. Ultimately, your friend what? Proves it nicely. Fine. You ask your friend to come in east and he goes to northeast. Fine. Somewhere he goes or she goes. You know about your friend. Fine. Especially best friend. Equal to trouble. Fine. So this way it happens. So you are trying to tell your friend, you are trying to convince your friend, you are giving the cues, directions, everything that is possible in your limits. But each and every time, fine, your friend manages to speak. What will you do? Exactly. Fine. What will you do now? You will go directly. எப்போ நீ அங்கே நில்றான், நான் வரேன். Am I right? Am I right? That is the most important thing. So the first point that you need to understand is, whenever a value is continuously changing, whenever a value is continuously changing, it will be really difficult for you to handle it and substitute it in any mathematical operation. So first thing, if you want to use that particular information which is continuously changing, then first thing that you need to do, what's that? You have to stop it to check it. You have to stop it to check it. See, for example, let me take a velocity of a body. I want to calculate the velocity of a body which is continuously increasing. Let's assume that I have a slope. On the slope, I just left a ball is rolling. You know very well, when I leave it, ball is slower. As it comes down, it picks up the speed, because acceleration due to gravity is pulling it at a rate of 9.8 meter per second squared. So at point to point, the speed of the body would be what's increasing. So I really want to know what is the speed of the body at this particular spot. I find a part. So let's imagine that I have a small ramp. So I have a ball which is rolling down, and this ball is rolling and coming here. I know this is the initial velocity u is equal to 0 and final velocity v is equal to some number. Fine, sir. And I really want to know the velocity at this point. I want to know the velocity at this point. What do? As I told you, the velocity is continuously changing. I just stop it here. What will happen? Velocity turns 0. Right or wrong? If I try to stop it here physically, velocity will become what's 0. Then what are you supposed to do is, you have to stop it mathematically. You have to stop it what's mathematically. Got it? So here we have a beautiful tool called integration. That helps you. Got it? So integration is a mathematical tool which we use to convert any value which is changing. If you want to bring it down to a steady value, then you will use what's integration. Let's imagine now the situation. Okay. You told your friend to stay at the same spot. You told your friend to stay at the same spot, but that moron doesn't listen. Fine. What he does, he continues to come. At least now what will you come again? Stop. Okay, you are telling him to stop or her to stop. Here she is not listening. Now he says, I'll definitely come. What will you say? Bare minimum say, hey, it's okay. நீயும் வா, நானும் எதிரில் வரேன், கொஞ்சம் ஸ்லோவா வா, குத்துன்னு போய் எங்கேயாவது போயிடாத. ரைட்டா ராங்? Practically speaking. So bare minimum, if you are not able to stop the guy, minimum you will slow him down. So whenever there is a change that is happening rapidly, if you substitute this integration tool, you bring this tool called integration, what this will do, either it will try to stop the body, that is stop the change, or it will try to what? Slow down the change. So how do I know whether the change is happening at a higher rate or a lower rate? Very easy to find. See, you will find that in this way. D by dx, or you can just say d by எக்ஸே இருக்கட்டும். என்ன இது தெரியும்னா இப்போ நான் அடுத்து உங்களுக்கு கிராஃப் டீச். Definitely I'm going to teach the graph also. Graph reading. Today's topic is actually in yesterday's, day before yesterday's class was lines and curves. Fine. So how the lines are working, how the curves are working. That was day before yesterday's session. And today's session will be the graphs and changes. Fine. The functions and changes. We will discuss that. Okay. So now every one of you is aware of, I hope so, this, what do we call it? How do we call it? இதுக்கு என்னன்னு பேரு, என்னன்னு சொல்லுவீங்க இதை? F of x. You call it what? F of x. What do you mean by f of x? அப்படின்னா என்ன? அப்படின்னா என்ன? Come again? If you substitute, then it will become 0. So I can just straight away take f of x is equal to 0. I can make LHS is equal to RHS, multiply by 0 on both sides. We generally do all the time. We try to irritate. If you really want to irritate your math teacher, take a very complex numerical problem and multiply by 0 on both ends. Then LHS is equal to RHS. Try to prove. Fine. I have done it to my math teacher. So he cursed me. You become a teacher. So I am a teacher today. Fine. So come on, children. Tell me. What do you mean by f of x? யாராவது ஒருத்தர் சும்மா ட்ரை பண்ணுங்க, என்னவா இருக்கும்னு. Oh, what equation? N. Okay, linear, cubic. Fine. So I'll tell you what is it. Nothing but it is trying to tell you a graph. It's trying to just express something about a graph. See, for example, what is a graph? In general, this is what we generally call the Cartesian coordinate system. In Cartesian coordinate system, we have the x, y, z graph. So this is x, this is x, and that is y. You have x and y. If you have difficulty, you can just put it here and sit comfortably. Ask them to little bit move. They'll be happy to. Yes. He's not able to see clearly. That's good. Okay. Happy. So x and y. We have x coordinate and we have y coordinate. What am I going to draw in this x and y coordinates? It could be anything, sir. It could be anything. That is total quantity or total amount of charge in my mobile phone. Now I have somewhere around 40% left in my mobile phone. 40% is, so the total quantity of the amount of charge is denoted as q, and time. Okay. So what happens when the time is equal to 0? When I start to observe, charge is at its peak. Fine. So let's take this is midnight 12 o'clock. Take this is midnight 12 o'clock. So midnight 12 o'clock, my phone's charge was somewhere around maybe we can say 25%. Let's take it 25%. Midnight 12 o'clock today. Then I woke up at 4 o'clock today. As soon as I woke up, I switched off the phone, alarm, then I kept it for charging. At that time, the charge has come really down to somewhere around 16%. So morning, I put it in charging. So up to 6 o'clock, I did not touch it. So it goes high all the way to 100. So exactly at 6 o'clock, I turned it off. Fine, I left it. Since then, I have been using it. I put it in my pocket and I went to school. I did my work today. In between, I attended calls. So finally, now I have come here. Around 40% is left. So if you just see, in between during my lunch break, I took my phone and I started checking. So definitely at that time, the charge would have come down because the screen is on. I've been checking some emails and the other stuff. Fine. Thereon, it has started to decline at a steady rate. So if you just observe the entire journey of the mobile phone's charge with respect to time. So I can say now the quantity of charge, the amount of charge present in my phone depends on the time. That is a function of time. It varies with respect to time. Am I right? Am I right? What I mean when I say f of x. Y is equal to f of x. The value which is present on the y axis is going to vary when the quantity on the x-axis varies. Got it? Got the idea? So what do you mean by f of x? F of x is nothing but your graph, an xy graph. In my humble opinion, children must be taught to read graphs just like the way they are reading the alphabets and numbers. Graph is also a beautiful and intellectual way of communicating. Okay? Yes, sir. Energy or the charge? Charge. According to the sometimes it increases, sometimes it decreases. But it varies. So I am telling that to you. The charge, here I observe the charge as a function of what's a time. So the same charge can be considered as a function of usage. So here if you just take from the morning 6 o'clock, it was at the peak value of 100%. And now it has come down towards somewhere around 40%, let's suppose that. Fine, sir. Suppose if I imagine if it is a Sunday, morning, I pick my mobile phone and I start to play video game with it. So I played for around 1.5 hours. Within 1.5 hours, from the 6 o'clock to 7:30, charge would have rapidly come down. Otherwise, I take online class with my mobile phone. Let's assume that within the 1.5 hours, the same charge amount of charge, it would have come down. Right or wrong? Right or wrong? That is very important thing. So here the charge can be a function of usage also. If that is the case, I have to mark the graph this way. Which way? Charge on the y-axis, and the x-axis I have to mark the usage. So if my usage increases, charge will decrease. Right or wrong, sir? Right or wrong? So here the charge in my mobile phone is observed in terms of time. Here charge in my mobile phone is observed in terms of usage. So here we call q as a function of usage. Here we call q as a function of time. So simply you can say any quantity present in the y-axis, any quantity that is present in the y-axis is a function of quantity present in the x-axis. Am I right? Am I right? Okay. So now if I try to say y is equal to f of x is equal to 0. Y is equal to f of x is equal to 0. See, for example, let me say the quantity of the charge in my mobile phone. Quantity of charge in my mobile phone. That I am going to draw on the another graph I ask you to plot now. Plot a graph between quantity of the charge present in my mobile phone with respect to ability of my cat to run. Ability of my cat to run. So let me write on the x-axis I have ability of my cat to run. சொன்னாங்க பிசிக்ஸ் படிச்சவங்களாம் ஒரு மாதிரி தான் இருப்பாங்கன்னு கேள்விப்பட்டிருக்கேன். So tell me, what's the relevance here? Nothing. So it is independent. Got it? It is independent. So the graph would not vary. The graph would take a parallel line. Graph would take what? A parallel line. Got it? Noted? One more. Please. Sir, namaste. Sir? Namaste, sir. போட்டுடலாம் சார், போட்டுடலாம் சார், இருக்கு சார், போட்டுடலாம். ஃபைன் சார். Fine. Got it? It is independent. So a graph can tell you the value of the quantity on the y changes with respect to quantity on x, or it does not vary. So a graph is a beautiful way of representing the exact relation between the given quantity. So I am taking what's a f of x. What do you mean by function of x? Henceforth, if anybody asks you in lower class, you must have learned the f of x somewhere. Where did you learn the f of x? In grade 10 or 9? 9. So 8th itself you learned. Excellent. Where did you learn? In linear equations. There? Polynomial. Okay, polynomials you have learned f of x. Okay. So the moment when I say that the quantity on the x-axis and y-axis, they are related. So f of x, if I write y is equal to f of x, then definitely you can say what? The quantity on the x and y are related. First example, I would say the well-known equation. I'm going to pick up a well-known equation to you, and I'm going to explain this function there. We are going to plot a graph. We are just going to plot a graph. Shall we? Yes. Now let's take here the gravitational attraction between two masses is equal to gravitational mass, right? Force between the two masses equal to g into mass 1 and mass 2 divided by distance square. Divided by what's that? Distance square. This is a equation everybody knows. Am I right? What do you call this equation? What do you call this equation? Grade 9. You must have learned this equation. What do you call this equation? Newton's law of gravitation. What do you call it? Newton's law of gravitation. Isaac Newton gave this equation to us. We call this equation as the Newton's law of gravitation. Am I right? What's the value of g? You can recall. You recall? G, value of g, gravitational constant. No, that is small g. 9.8 is small g is equal to 9.8 meter per second squared at Earth's surface. If you go beyond the Earth's surface, this value will vary. If you go near the moon, this acceleration due to gravity will not be 9. So the moment when the radius, the distance becomes half of the radius of our Earth. What's the radius of our Earth? 6,400 kilometers. So I start from this point. Fine. I move upward somewhere around from the surface. If I move half of this one, how much is the half of this one, sir? 3,000 through 3,200 kilometers. If I travel, then definitely my acceleration due to gravity at this point will not be equal to 9.8 meter per second square. No, it will not. It will reduce. It will come down as we go away from the Earth. So the maximum value that we can observe, the average value that we can observe on the surface of the Earth is 9.8 meter per second. You must have learned it in grade 9 gravitation. Have you learned it? Different acceleration due to gravities of different planets and satellites. Acceleration due to gravity on moon is 1/6 that of Earth. Learned it? Just a refresher. Fine. Noted? Yes. So here we have a situation. Now, did you recall what's the value of G? Did you recall what's the value of G? You can say, Sadhana, can you say what's the value of G? If you don't know, no problem. Oh, fine. Problem. Anyone who recalls? Will you find out and come day after tomorrow's class? Fine. Day after tomorrow's class, will you find out and come? Sir, if you're getting a day after tomorrow, I will not. Hmm? Yes. Yes, sir. Tell me. Yes, Rohit. Wait a minute. That is small g varies, capital G doesn't. Capital G is called as universal constant. You go anywhere in the universe, this value should remain constant. Capital G value is a fixed number, it will not vary. Anywhere in, yes, capital G is called as universal gravitational constant. This is called as gravitational constant. Okay, and the G stands for acceleration due to gravity. Okay, very good, very good. 6 point. One moment. Please children, one moment. Hello. One. வீடு திறந்துட்டா போட்டிருக்கா சார்? கேன் யூ ப்ளீஸ் இங்கே வர முடியுமா? வேற ஒரு லொக்கேஷன் சொல்கிறாங்க, வர முடியுமா உங்களுக்கு? நான் இப்போ வெளியில் இருக்கேன், மெயின் ரோட்டில் நின்றுட்டு இருக்கேன். கேன் யூ ப்ளீஸ் கம் ஹியர்? ஹலோ. அதர்வைஸ் டூ மீ ஃபேவர் சார், நீங்கள் ஒன்று பண்ணுங்கள். நீங்கள் அதை வீட்டில் நம்பர் 1 இருக்கு இல்லையா, நீங்கள் லெஃப்டில் முதல் வீடு, லெஃப்டில் முதல் வீடு ஒரு ஒயிட் கலர் கார் இருக்கும் பாருங்கள். ரைட் கட் பண்ணீங்க இல்லையா, லெஃப்டில் ஃபர்ஸ்ட் வீடு. யூ ஜஸ்ட் ட்ராப் இட். இல்லை, ஆன்லைனில் பே பண்ணிட்டேன். நீங்கள் கொஞ்சம் அப்டேட்டில் செக் பண்ணுங்கள். பெய்டு வச்சிடுங்க. தேங்க்யூ. எஸ். For that, so here we go. This is acceleration due to gravity. This gravitational constant. This rendu totally different quantity. Fine. So this is acceleration due to gravity, and this is gravitational constant. They are totally different quantities. It's a fixed number, and universally this number does not vary, but this number varies from point to point. Okay. Fine. So here we go. You know, you must have heard that the mass is a conserved quantity that does not vary from point to point. Only the weight varies from point to point. So here in this equation, gravitational constant and mass 1, mass 2, then their product must be what's a constant. So if that is the case, can I write all these three multiplication of all these three numbers into f is equal to some constant k multiplied by 1 by r square? What is k? G into m1 into m2. Can I write it like that? So if that is the case, I can write f is proportional to 1 by f is proportional to 1 by r square. That is, the force is depending on the square of the distance inversely. Am I right, sir? The force depends on inverse square. That's why this law is called as the inverse square law. So this law is called as what's a inverse square law, if you have heard of it. So now if I ask you to plot a graph to represent this function, If I ask you to plot a graph to represent this function, can you plot a graph to represent change in force with respect to change in position? That is the distance. R is the distance and F is the force. You know very well. Here, force is a function of R. Can you write force is a function of R? That means if the R changes, force will change. That's what it means, right? That's what it means, right? So can you please plot a graph to represent force as a function of R? Completed? Just a simple thing it is. Yes, sir. Nice, sir. Good, good, good. Let's see. Let's see. Please wait. Let's see. It's a nice attempt. You, Sadhana, can I see your graph? Yes, Sadhana also has done the same kind of graph. Okay. And Mole, what's your name? Riya. Riya also has done the same kind of graph. Good. Okay. So obviously you all have done the same kind of graph almost except you two. Fine. You all have done some graph, something like this. You have taken the force on the y-axis and the distance on the x-axis. But I know very well they are inversely proportional. What is the meaning of this one? Whenever this quantity increases, this quantity will decrease. That is the inverse proportionality means. What's the meaning of inverse proportionality? If the quantity on the x increases, quantity on the y will decrease. This is inverse proportionality. But here they are going to decrease in the square. But I have taken the graph for f versus r. But there it is f versus r squared. If it is just f versus r, then what you have drawn, this is correct. Fine, sir. So here you have taken the f versus r. So the reduction has to be exponential reduction. The reduction has to be exponential reduction. Got it? இது எப்படி சார் ஐடென்டிஃபை பண்றது? It's very simple. கவனிங்க. I'll tell you another graph. It may give you some better clarity. You know very well. V depends on I. V depends on I. You know what? Am I right? In a piece of wire, the current flow depends on the ability to push. The flow depends on what? Our ability to. So I may write E is equal to some constant. It could be any constant. We named the constant as what, sir? Resistance R times I under the steady temperature. Under the steady temperature, we have taken it. And if I ask you to plot, I can say V as a function of I or I as a function of V. I as a function of V. So I want you to plot a graph. I as a function of V. How would you plot a graph? Very simple. On the y-axis, you take what's a I, and on the x-axis, you take what's a V. Then how will you draw? Because they are directly proportional. If the I increases, V should also increase. If the V increases, I should also increase. So you may write this as a straight line like this. Am I right, sir? Am I right? Yes, sir. Is it? 1 minute. Noted. Here you have a graph. Watch, children. Something very peculiar about this graph. Very peculiar about this graph. Okay. See this? V proportional to I. V is proportional to I. Or you can just say V is equal to I times R. Suppose if I bring this one here, what do I get? B divided by I should be equal to, which is a constant. So instead of R, I can write this as constant. Vy should be equal to what? Constant. Here we have a name for the constant. Otherwise, if you don't know the name, then you can simply call it what? Just a constant. Agreed? Agreed. So what's this? V by I should be equal to what's a constant. So how do you recognize this V and I are changing at the constant rate? It is seen in the shape of the graph. So the graph does not just tell you whether the value is increasing, decreasing, or remains the same. It also tells you in which way it is increasing and decreasing. In which way it is increasing and decreasing. So if you get to see this kind of straight line graph, you can say the variation is happening at a steady rate. Variation is happening at a steady rate. Suppose if you get to see this graph is curvature, immediately you can recognize that the variation is happening at non-steady rate. What do we call it? Exponential rate. What do we call it? Exponential rate. So if you want to get your graph, children, 1, 2, 3, 4 of you have drawn the graph this way. Force versus R, you have drawn this way. Suppose if you want to make it true, if you do only one alteration in your graph, you don't have to touch anything in the shape of the graph. You don't have to touch anything in the shape of the graph. If you alter something else in your graph will be a valid one. What is it? Excellent. R has to be what? R squared. If you just make it R squared, then that graph is correct. Why? It's very easy. Where is the formula? Here is the formula. Here's the formula. So if you just bring it, f is equal to some constant multiplied by 1 by R squared. If you take it to the other side, what will be remaining? Constant. What will be remaining? Constant. Got the idea? Got the idea here? So if the 8th or 9th grade geometry teacher, they teach the graph in way to children, it will be much better. What are they trying to say in these graphs? Ideally, I planned the graph for the next session. It's okay. Graph படிச்சாதான் கிராஃப்ல இருக்கிற மேத்தமேட்டிக்ஸ் படிக்கணும், அது படிச்சாதான் கால்குலஸ் படிக்கணும். So it's an introductory session to calculus. When I was doing my advanced calculus from Harvard, the Harvard professors, they told I am not eligible to take the class. I am not eligible to sign up for the class in Harvard. They told me you have to finish one pre-calculus course, then only you will be able to. So I finished a pre-calculus. We have to study a pre-calculus course, then we have to study the calculus course. If both are done, then they will take me for physics class. Then I did my MIT. In MIT, I did the physics course. Fine. American system is, in our school, we just take everything. Come. Let's mug up this formula. Let's see this here. Something very interesting. So I am telling you here, some quantity is varying with the other quantity. If I, with respect to y, the function of x, y is equal to f of, what do you mean by that? Value of y is going to vary with respect to x. இதுக்கு சிம்பிளா சொல்ல போனா x மாறினா y மாறும். இதுதான் இந்த ஃபார்முலாவுடைய பிராக்டிக்கலான அர்த்தம். இதை நீங்க ப்ரொனவுன்ஸ் பண்ணா எப்படி ப்ரொனவுன்ஸ் பண்ணணும்? இந்த ஈக்குவேஷனை x மாறினா y மாறும், x உடைய வேல்யூ மாறினா y உடைய வேல்யூவும் மாறும். அவ்வளவுதான். இதுதான் இதோடைய மீனிங். நெக்ஸ்ட் கம்ஸ் தி நெக்ஸ்ட் ஸ்டேஜ், செகண்ட் லெவல் இன்ஃபர்மேஷன் கம்ஸ். இப்போ y மாறினா x மாறினா y-யும் மாறும். இப்போ x-உம் y-யும் எப்படி மாறுறாங்க? ஸ்டெடி ரேட்ல மாறுறாங்களா இல்ல நான் ஸ்டெடி ரேட்ல மாறுறாங்க? எஸ், தட்ஸ் தி நெக்ஸ்ட் क्वेश्चन. y is proportional to some value. Next, clear? இப்போ y மாறினா x மாறினா y மாறும். இந்த ஸ்டேட்மெண்ட். அடுத்த கேள்வி, y இன்க்ரீஸ் ஆனா x என்ன ஆகும், இல்ல x increase ஆனா y என்ன. There should be a relevance between these two quantities. Fine. How do we represent it? We represent it using numerator and denominator. If I write it this way, I mean x ஜாஸ்தியானா y ஜாஸ்தியாகும். நல்லா கவனிங்க. What is the first statement? x மாறினா y மாறும். What is the second statement? x ஜாஸ்தியானா y ஜாஸ்தியாகும். ரெண்டுக்கு என்ன வித்தியாசம்? First statement is trying to say if the x changes, y will also change. The word change here, change, can be both reduction as well as increment. Can be both what's that? Reduction as well as increment. Agreed or not? Agreed or not? Right? So that information is not given by the first statement. First statement is little bit incomplete. First statement is just trying to tell you what's that? What does it tell you? If the x changes, y will also change. But it doesn't say if the x decreases, what will happen. What happens if the x increases? What will be the effect of the rise or fall in the x on the value of y? That information is not clear. But this one is trying to give you that. This one is trying to say if the x varies, if the x increases, y will also increase. Or in other words, I can say it in this way also. Y is proportional to 1 by x. Y is proportional to 1 by x. Got it? Got it? So this is the secondary level information. This is the secondary level information. More clear to me. If the x increases, y will also increase. If the x increases, then the y will decrease. Y will decrease. So சும்மா இது மாறினா அது மாறும்னு சொல்லாம இது கூடினா அது கூடும், இது கூடினா அது குறையும்னு இன்னும் கிளியரா சொல்றேன் நான் இந்த ஸ்டேட்மெண்ட் மூலம். ஓகே, நவ் கமிங் டு தி தேர்ட் ஸ்டேட்மெண்ட். இதை விட இன்னும் பெட்டரா ஒரு ஸ்டேட்மெண்ட், இதை விட இன்னும் பெட்டரான ஒரு ஸ்டேட்மெண்ட் சொல்லலாம். என்ன சார் ஸ்டேட்மெண்ட் அது? எஸ், மூணாவது ஸ்டேட்மெண்ட். y is proportional to x squared. That is x to carry a non-zero and non-1 power. X to carry a power. It could be any power. X to the power n. Where n is not equal to 0 and not equal to 1. N is not equal to 0 and not equal to 1. Got it? Plus or minus. That's much better. If the n is not equal to 0 and not equal to plus or minus 1. Under this condition, if y is proportional to x to the power n, or you can say y is inversely proportional to x to the power n, where the n is not equal to 0 or plus or minus. Got it? இப்போ இந்த ஈக்குவேஷன் என்ன மீன் பண்ணுது உங்களுக்கு? இது என்ன சொல்லுது? இது என்ன சொல்லுது? x சேஞ்ச் ஆனா y சேஞ்ச் ஆகும். இது என்ன சொன்னது? x ஜாஸ்தி ஆனா y ஜாஸ்தி ஆகும், இல்ல x ஜாஸ்தி ஆனா y குறையும். ரைட் ஆர் ராங் சார்? இது என்ன சார் சொல்லுது? எக்ஸ்ல கொஞ்சம் ஜாஸ்தியானா ஒய்ல ரொம்ப ஜாஸ்தி செய்யும். அதாவது எக்ஸும் ஒய்யும் ஒரே ரேட்ல இன்க்ரீஸ். எஸ் சார். rapidly. Got it? Got it? Yes. Which one? Which one? Very good. Very good. Second case is steady, and third case is not steady. That's correct. Got it? Got it? So now I told the world if the x changes, y also changes. Then I made it more clear to the people. If the x increases, y will also increase. Or the x increases or decreases, the y will go in the opposite way, other way around. So we call this direct proportion. We call it inverse proportion. We call it direct proportion, and we call it what? Inverse proportion. And what do we call this? We call this as steady proportion. Watch the board, children. Watch the board. Look at the board. Look at the board. Look at the board. Okay, fine. So what do we call this? We call it steady proportion, and we call it exponential proportion. We call it steady proportion, and what do we call it? Exponential proportion. That means what's our even a slight change in x. In this case, even for a slight change in x, y will experience a rapid change. That means what's our y becomes more sensitive. Y becomes what's our more sensitive to x. So this relation gives me the order, the power that gives me the sensitivity of the change. What do you mean? Who is this very sensitive person in your school, in your class? There must be definitely one fellow or a felly, right? Who is a very, very sensitive person in your class? Don't name the person. You know a person. That person is extremely sensitive in your class. Why do you call that person very? Yes, yes, your friend, of course, your friend. Why do you think your friend is so sensitive? Exactly. Even if you do very little thing, he will cry. That is, even for a small disturbance, he will react to. Fine. Watch this. If I plot a graph here, the behavior of his friend, even for a very small disturbance in the x-axis, and his mood in the y-axis. Even for a very small change of disturbance, if you just lightly increase the disturbance, his mood will rapidly come. Got it? When your x-axis value is rising little, the y-axis value is dropping rapidly. But there are some friends. Fine, sir. You annoy them. No matter what. Their mood versus your disturbance. That will be. They wouldn't mind. And there are some friends. Fine, sir. You make fun today, they will go one step away. Then you continue the same behavior tomorrow, they'll move two steps away. You continue the same behavior for about a month, they will vanish from life slowly, like smoke. They will vanish, no trace. At a steady rate, you can see them declining. Right or wrong, sir? Right or wrong, sir? Whereas here the changes are equal. Fine, sir. Here the changes are equal, you can see. Equally they change. Got it? Something very interesting here. So this equation, the third form, which I have written here, 1 to third form, is talking about the sensitivity of the change. Sensitivity of the change. Maybe the words may be very fancy, but what do they mean is very important too. So the third set of equation tells me it is the sensitivity. So now I have a situation to describe the equation which we have in our hand. What's the equation that I asked you to plot as a graph? Which equation did I ask you to plot as a graph? I asked you to plot the variation of the force of gravity as a function of distance. And I found that force is equal to G m1 m2 over r squared. G m1 m2 over r squared. So if you just write this equation, F depends on, put together all these as a constant k multiplied by 1 by r squared. Now I can say is equal to, not proportional to. So F is proportional to 1 by r square. Now you tell me, where does it fit? First one, second one, or third one? Where does it fit? It fits in the third one. So what kind of graph it should carry? It should carry an exponent graph. Exponent graphs are always what? Curvy. Got it? Exponent graphs are always what, sir? Curvy. They are not straight line. Noted? Fine. And there comes the fourth form, the highly robust form of this entire lineup. I'm going to write the fourth and most robust and steady form of this entire lineup. I'm going to say the fourth form is equal to, I am not going to use this, I am going to use someone very authoritative. The equal symbol is most powerful symbol in mathematics, because this symbol tells இதுதான். See, for example, you say 4x plus 2 is equal to 10. 4x plus 2 is equal to 10. What is x? 2. What is x, sir? 2. Is there any other number that can play a role here? Definitely not. So this equation tries to tell you very authoritative information. This entire statement is true only if x is equal to 2. Right or wrong, sir? So equal symbol is the most authoritative mathematical operator. Equal symbol is what? The most authoritative mathematical operator. So bearing that in mind, let me take y is equal to, what is it, sir? I am going to introduce a constant multiplied by x to the power n, or I am going to write y equal to some constant multiplied by 1 by x to the power n. Or it could be this way also, y is equal to k times of x, or y is equal to k times of 1 by x, whichever the way it may be. You just take this fourth form that tries to tell you something very authoritative. Gavani. Rohit, I'm not able to see your video, Rohit. Watch this. First statement. It's okay. Take your time. So if this one says if the x changes, y also changes. This one says if the x changes, y also changes. But if the x increases, y increases. If the x increases, y decreases. Fine, sir. And what is this number, sir? If the x changes by 2 times, y will change by 4 times. If the x changes by 3 times, y will change by 8 times. Some number there must be. இவங்களுக்கு நடுவில் ரிலேட் பண்ற மாதிரி ஒரு நம்பர், and that number is what we generally call as proportionality constant. Proportionality constant என்ன சார் சொல்லுது? Always remember proportionality constant. You must have heard this term, proportionality constant. Upon the constant is trying to tell you something. What is it? It tells you the exact relation between the x and y. The precise relation between what's a x and y. Got it? So now I am going to show you other beautiful way. Fine, sir. Another beautiful thing to observe in a graph. Shall we? புரியுதா கிளாஸ் புரியுதா உங்களுக்கு? ரொம்ப மேத்தமேட்டிக்ஸா சவுண்ட் ஆகுதா? அப்படிதான் இருக்கும். Because the first course for the first 4 days will be mathematical physics. இது புரிஞ்சதுக்கு இது முடிச்சு இது வந்து ஒரு பிரிட்ஜ் கோர்ஸ் மாதிரி 10th ல இருந்து 11th வர குழந்தைங்களுக்கு பேசிக்கா நீங்க என்னென்னலாம் எதிர்பார்க்கலாம் அப்படின்னு உங்களுக்கு சொல்ற ஒரு கோர்ஸ். இது முடிச்சதுக்கு அப்புறமா then we will go to units and after the 5th session we will go to units. Okay? Yes, sir. No, don't go for that word median. Median is mathematically different. Depends upon y depends on x. That is correct. And at what rate is given by the constant. How much y is dependent on x is defined by the proportionality constant. Got it? So now let's see. I am going to tell you. I am straight away telling you an information. I have two quantities. Let's take velocity and time. Let's take what's the velocity and time. Fine. You know velocity and time. I'm going to study the relation between the velocity and time. When the time changes, velocity also changes. So I can write the first statement. What's the first statement? When the velocity changes, when the time changes, velocity also changes. So I can write velocity is equal to a function of time. And the simpler form of this one, how do we write? V as a function of time. Don't study this, don't read it as for V multiplied by T. So you are expected to read this in way V as a function of time. இது ரெண்டும் ஒண்ணுதான். Okay? Noted? So v as a function of time. இது மூலமா நான் உங்க எல்லாருக்கும் என்ன சொல்றேன்? டைம் மாறினா வெலாசிட்டி மாறும்னு. இப்போ அடுத்த ஸ்டேஜ்ல நீங்க என்ன கேள்வி கேட்பீங்க? சார் டைம் ஜாஸ்தியானா வெலாசிட்டி ஜாஸ்தி ஆகணுமா கம்மியாகும்? அதை நீங்க எப்படி சொல்லுவீங்க? டைரக்ட்லி ப்ரொபோஷனலா, இன்வெர்ஸ்லி ப்ரொபோஷனல்? That's the next question you children would ask. Am I right? So now I am telling both are directly proportional. If the time increases, velocity also increases. I told that. What's the relation between the velocity and time now? If the time increases, velocity also increases. I can represent it in 3 different ways. I will show you what. First way of representing this condition is velocity versus time. Velocity versus. So when the time increases, velocity is going to increase simultaneously. So I can mark it this way. Starting from the 0, it increases. இதை பார்த்தோன்னே தெரிஞ்சிடும். சார் டைம் கூட்டிகிட்டே போகிறது, velocity value is also what? Rising. Put it silent. Got it? Time ஜாஸ்தியான என்ன ஆகும்? Velocityயும் ஜாஸ்தியா. That's it. This information is very clear to all. Now sir, second graph. Velocity versus time. Velocity versus time. Time ஜாஸ்தியான என்ன ஆகும்? இப்போ velocity ஜாஸ்தி ஆகும். டைம் ஜாஸ்தி ஆகும்போது வெலாசிட்டி என்ன ஆகுது? இப்போ ஜாஸ்தி ஆகுது. இங்க டைம் ஜாஸ்தி ஆகும்போது வெலாசிட்டி ஜாஸ்தி ஆகுது. கரெக்டா? கரெக்டா சார்? ஓகே. வெலாசிட்டி கண்டிஷன் என்ன சொன்னேன் உங்கள்கிட்ட? டைம் ஜாஸ்தியானா வெலாசிட்டியும் ஜாஸ்தியாகும். ஓகே பாருங்க, டைம் கூட்டிகிட்டே போறதா, velocity is also increasing, time is increasing, velocity is also increasing, time is increasing, velocity is also increasing. Am I right? Am I right? ஆமாவா இல்லையா? அப்ப இந்த மூணுக்கும் நீங்க எப்படி வித்தியாசம் சொல்லுங்க? Statement is same. Statement is same. The time changes, velocity also changes. Statement is same. How will you give the difference in these 3 cases? No. Velocity and time are not constant. They are changing at steady rate. Don't say constant. Okay, steady rate. Uniform means this will become like this. If the velocity is uniform, then with respect to time, velocity will turn like this. So use the word, yes. Uniform acceleration, that's correct. That's correct. Constant acceleration, that's correct. Yes. Very good, very good. Second and third are exponentially proportional. First one is what's a steady. First one is what's a steady. And which quantity is steady in this? Which quantity is steady in this? Which quantity is steady in this? Yes? No. Which quantity is steady in the first graph? Which quantity is steady in the first graph? Say it louder. Acceleration is steady in the first graph. Why do you say so? Because, sir, I know you take any place, the slope of this graph is constant. Slope of this graph is what, sir? Constant. What do you mean by slope of the graph? Change in value of y divided by change in value of x is called as slope. I hope you remember y by x is equal to slope. you must have studied. Change in y divided by change in x is called as what, sir? Slope. கேள்விப்பட்டிருக்கீங்களா? Have you heard of this in geometry? You have not? Then if it is now, what do you call the slope is? Slope na enna meaning? Change in y divided by change in x. That's what the slope. Yes, sir. Sure. For the second graph, I'm coming. I'm just doing only for the first graph. Second and third will come now. So generally, in any graph, children, the value y divided by x is going to be what's a slope, and the value y multiplied by x is going to be area. There are two mathematical operations that are allowed in any graph. For graph எடுத்துட்டீங்கன்னா ரெண்டு mathematical process are allowed. What are they? First process is the change in y multiplied by change in x called as slope. Second, change in y multiplied by change in x, or generally y multiplied by x. What do we call it? We call it area, because it's just a graph, a rectangular graph. Value on the one side multiplied by value on the other side is called as what? Area. Right or wrong? It is area. Got it? இப்போ நீ இந்த இந்த velocity time graph எடுத்துக்கோயேன். You take the velocity and time graph. Let's find the slope of this velocity and time graph. Tell me, what's the slope of a velocity time graph? Slope of the VT graph be equal to what's that? The quantity on the y-axis and the quantity on the x-axis is equal to time, which is equal to v by t is acceleration. So the slope of this graph gives me, suppose if I take area of the graph, what is the area? Velocity multiplied by time. So velocity multiplied by time, what does it give me? It gives me displacement, because I know displacement is equal to displacement divided by time is equal to velocity. Am I right? Displacement divided by time is equal to velocity. I hope you remember from grade 9. So what is displacement? Velocity into time. Right or wrong? Now do I sound like a physics teacher? So the area under the graph is called as what's a displacement. So this graph simultaneously gives me two information. One about the acceleration, second is about what's a. If someone is giving you VT graph and they are asking you to calculate what is the velocity at the given time, you can do. What is the time when the body was traveling with particular velocity? They are asking the time, you can find out. So using this graph, you can find velocity, you can find time, and the relation between the V and T, relation between V and T. Fine, sir. First quantity, second quantity, third quantity. Answer. These are the direct quantities which we can find. And there are two hidden quantities in this. What are they? Slope. Slope gives me acceleration. And the third hidden quantity, what is it, sir? Displacement, area. That gives me displacement. So there are three explicit quantities and two hidden quantities that are present in this graph. The explicit quantities are found by the coordinate, and the hidden quantities are found by area and the slope. Area and the, got it? So now comes the most important question. Sir, here it is very easy for me to find out the slope. Here it is very easy for me to find out the slope. You can just, if you want, try. If you want, just want to try, you can just try it. Fine, sir. You draw a straight line in your paper. You draw a straight line in your paper, a very long straight line in your paper, right? Across a diagonally straight line in your paper using a scale and pencil. If you want to try, you can try. Okay, fine. Let's try that out. Let's try that out. You take scale, you take pencil. Fine. And draw a long line. Come again? Enough. You draw. Let's try this activity today. Done? So now you have taken a straight line. Sorry. a slanting line like this. Yeah? You choose any point on, you choose any on this line, choose any point. Suppose I choose this. I choose this. Okay. From this point, you draw a straight line for some distance, any distance, a small distance. The distance வரைஞ்சுக்கோங்க, ரொம்ப பெருசா வேண்டாம், and measure the distance and write down. Measure the distance and write down. Okay. So I may call this distance as 3 centimeters something. Noted? Noted, children? Yes. Now draw a perpendicular line to this and connect it to the graph. Now measure this length. How much is that? Some number. It could be 2 centimeters, 3 centimeters, some number. I don't know what number, sir. You measure and write. 1.7. So for you, your value is 1.7. And her value could be something different. Have you measured the number? Have you written it? Some number. Have you written that? So for me, let me write this is approximately 5. For something like that, I write. Fine. Now I want you to find the 3 divided by 5. This number divided by this. Whatever the number that you have found, this divided by calculated. Over, sir. Rohit, over. You keep that number. Let's call this number as slope 1. We can call this number as what, sir? Slope 1, divided number, the ratio, final number. So how much is 3 by 5? How much is 3 by 5? 0.6. Quick, fast. My number is 0.6. Your number could be different. Note பண்ணிட்டீங்களா? Noted? Noted? Now let's see. Choose some other point now on your graph. Could be anywhere. Like last time, this time draw a different distance. Then, like last time, you connect. Then, completed. Now find out the ratio, y by x ratio. You have drawn two different lines, right? Two different length. Find out the ratio. Sadhana completed. Are they same? They should be same. Almost, maybe. Almost. Maybe it is because of your calculation. Rounding off problem. It could be rounding off problem. Got it? And if you just take this end and draw a vertical line, and this end you draw a vertical line, if you take this by this, that should also be the same, the ratio. You can just take this first height as y1, first length as what, sir? X1, this is y2, this is x2, this is y3, this is x3. So you can very well comfortably write in this case y1 by x1 is equal to y2 by x2, which is equal to y3 by x3. So whenever you have a straight line, this kind of slope calculation is always what's a constant, almost similar. If you round off for the numbers, you will get the same number. Are you getting? That's what, 1. The same number. It should be same. If you use some whole numbers which are easily divisible, then you will definitely get what? The same value. No matter whichever the direction you go, you will get the same number. நீங்க எவ்வளவு குட்டியா இந்த ட்ரையாங்கிள் போட்டீங்கனாலும் அதோட ரேஷியோஸ் எப்பவுமே என்னவா தான் இருக்கும்? சேமா தான் இருக்கும். Answer is very simple here. The answer is very simple here. You know very well. What is it, sir? In all these cases, angle is similar. In all these cases, angle is similar. Right or wrong, sir? If two triangles have similar angle, then the ratios of their sides must be equal. Right or wrong? Right or wrong? You take a crossed line and you mark a line here, here, here. All these angles are equal. Watch this. This angle is equal to this angle. It's equal to this angle. So these three bigger triangle, this little triangle and this medium triangle, all three triangles have what? Same angle. Then the ratios of their sides must also be what? Equal. You studied it in grade 10 geometry. What do we call this property? Similar triangle property. Similar triangle property. Using this property, people proved the law of reflection. இதை வச்சு தானே law of reflection prove பண்ணீங்க in 10th. Did you do that? No, never mind. You know laws of reflection, right? Incident light, incident angle is equal to reflected angle, incident light, reflected light, and the normal, they all lie in the same plane. இதை ப்ரூவ் பண்ணது இதை வச்சு தான் இந்த தியரம் வச்சு தான் பண்ணாங்க. லேட்டர் I'll teach. Fine, in 12th standard I'll teach. So my job just is to what, sir? Disprove whatever that you have learned in your lower class and going to introduce in 11th and 12th, which can be disproved in your college. Your lower class teachers must have told, இதெல்லாம் நீங்க higher class போகும்போது படிப்பீங்க. Fine. Generally, this is a standard statement told by every teacher. Just to take it for now. When you go to higher class, you will learn more about it. Am I right, sir? And I am telling you, just take it for now. In higher class, they will do. Fine. Just like the way I am disproving the ones that you learned in your lower class. All right. புரிஞ்சுதா? ஸ்லோப் நான் புரிஞ்சுதா உங்களுக்கு? சரி. இப்போ இந்த ஸ்ட்ரெயிட் லைனுக்கு இந்த ஸ்லோப் எந்த பாயிண்ட்ல எடுத்தாலும் என்னவா சார் இருக்கு? கான்ஸ்டன்டா இருக்கு. Now our common sense would immediately kick in and tell, sir, when I take this curvature, in this curvature, definitely what, sir? Slope is not going to be constant. Slope is definitely not going to be constant. Here the slope is constant and here the slope is definitely not a constant. அப்போ இந்த மாதிரி curvatureக்கு நான் எப்படி சார் ஸ்லோப் எடுக்கணும்? The curvature நான் எப்படி ஸ்லோப் எடுக்கணும்? I want to calculate the slope for the curvature. How would I take? Now you go back and recall the step-by-step process. What did we do? We took a slanting line. First, what was the next step I asked you to do? Choose a point. Very good. So now you are expected to choose a point on this curvature anywhere. You are expected to choose a point on this curvature anywhere. Then what's the next thing that you have to do? You have to draw a tangent. You have to draw a tangent. What do you mean by a tangent? Tangent is a straight line which is going to touch just one point of a curvature. Just one point of a curvature. The point is that the point where you want to calculate. So I am going to plot a tangent. So to that tangent, I will repeat the process. Got it? This is how I find the slope for a curved circle. For the curved circle. Got it? For a graph which is curved, I find it this way. Understood? So if the graph is linear, a straight line, then plot the graph, that is plot the slope, in which way? directly. Suppose if the graph is a non-linear graph, this kind of graph is called as non-linear graph. This is linear graph. This is non-linear graph. Noted? If your graph is non-linear and it varies, then what should you calculate, sir? Suppose wherever you want to calculate the slope, mark a point there. At that point, what should you do? First, you have to draw a tangent. Then, to the tangent, repeat the function. Repeat the process. Understood? Understood, sir? Yes. But the first fundamental question that remains unanswered here. What is it? What's the difference between these three graphs? Although all three graphs are trying to tell you what, sir? Velocity increases when the time is, but these three are telling different information also. They are telling all three are meaning the same. When the time changes, velocity also changes. Okay? But அந்த சேஞ்சில் ஒரு அர்த்தம் இருக்கு. என்ன அர்த்தம் இருக்குன்னு பார்க்கலாம். ஜஸ்ட் ஒரு சிம்பிளா பார்க்கலாம். இதே கேஸை இந்த வெலாசிட்டி டைம் கிராஃபா இல்லை டிஸ்பிளேஸ்மெண்ட் டைம் கிராஃபா பார்க்கலாம். டிஸ்பிளேஸ்மெண்ட் அண்ட் டைம் கிராஃபா பார்க்கலாம். உங்களுக்கு ரொம்ப ஈஸியாக புரிஞ்சு. ஃபைன். இப்போ நம்ம என்ன பண்ண போறோம்? இதே கிராஃப் தான். Instead of velocity and time, we are going to call it a displacement time graph. With that, we have just 3 minutes left. அதுக்குள்ள முடிச்சு நான் உங்களை அனுப்பிடுறேன். Because I have to start the 12th standard. Have they come? Boys have come? Is there any student waiting outside? Oh, yes, fine. Boys, you can say. Whenever you come, if the class is going fine, wait there. Sit. No problem, sit. Fine. So let's plot a graph here. So this is going to be what, sir? Displacement versus time graph 1 and displacement versus time graph 2 and displacement versus time graph 3. Displacement versus time graph 1, displacement versus time graph 2 and displacement versus time graph 3. I am going to plot 3 variations here. Variation number 1, variation number 2 and variation number 3. What do you mean by slope? Y by x. In this case, slope is constant. In this case, slope not constant, but it is positive. In this case, slope is not constant, but it is negative. What do you mean by that? Very simple. I take a ball and I throw a ball upward. So the moment when the ball leaves my hand, it goes upward. What happens to the displacement? Increases. What happens to the displacement? Increases. But simultaneously, what decreases? Speed decreases. As you throw the ball upward, slowly as the ball is approaching up, what happens to the speed of the ball? Decreases. Am I right? So when it comes to the speed, what gives you the speed? You have the displacement and time. What gives you the velocity? You have the displacement, you have time. How do you calculate the velocity? Displacement by time. What is displacement by time in our case? In our case, slope. What is it? Slope. So the slope of the ST graph gives what, sir? Slope of the ST graph gives me what? Velocity. Slope of the ST graph gives me what, sir? Velocity. Agreed? Agreed. And here it says velocity is constant. And here it says velocity is not constant, but the velocity increases. Here, slope says velocity is not constant, but the velocity decreases. Got it? Noted, sir? Noted? So just imagine that you take a ball and you just roll it in a smooth surface. Its speed continues to go in the same speed. So velocity is going to remain constant. No problem. So velocity is constant velocity. What do we call this motion? Uniform motion. And let me take a ball and throw it upward. So slowly the velocity is going to drop, and at a particular spot velocity will become what's a 0. So the displacement is increasing, but the velocity is decreasing. The ball has gone up and starts to fall down. Fine, sir. Let's imagine. Otherwise, you take a ball and you drop it. Now the ball is leaving your hand and displacement is increasing. The ball is leaving your hand and displacement is increasing. So displacement is increasing. Displacement is increasing. Then what happens to the speed of the body, sir? Raises. So here we have three types of graphs. In the first type of graph, the speed is constant. Second type of graph, the speed is positive, and the third type of graph, speed is the velocity is negative. Got it? So graph எப்படி வாசிச்சு இதுக்கு பின்னாடி என்ன மீனிங் இருக்குன்றத கத்துக்கிறது. This is what we call graph reading. What we call what's a graph reading. And when you do the graph reading, just only with the numbers instead of pictures, that becomes calculus. Got it? Fine. So we can discuss that in the next session. Little bit more of graph reading, and I'll give you some questions for you to practice. Then we will go to the calculus. All right. All right. Carry on. Carry on. Carry on.